Hello everyone, Mr. Hissner here, and today we're going to continue on with trigonometry and our trigonometric functions, and today we're going to be using it to find the side lengths of triangles. We're going to find the side lengths of triangles. Before we get started, I just want to take this time to just show you guys. I'm really trying to hit a fro hawk here, so hopefully in the next couple weeks we'll see how this grows in. Maybe I'll get a real fro hawk going. So just get that out of the way. Okay, let's see what we got. We want to find side lengths. We want to find side lengths with trig. We want to find side lengths with trig, and this is actually a lot easier than you might think. What do we want to do here? Well, let's say we have this here triangle, this here right triangle, and we're told that this angle down here is a lowly 28 degrees, just the 28 degrees. Then we're told that this side over here is some measure we want to find, and then our hypotenuse here across from the right angle is 19 units in length. And so what do we want to do? Well, first we want to find out which one of our trig functions do we want to use. And so I'm just going to write them here. This was adjacent over hypotenuse, and then finally we have tangent, and this is opposite over adjacent. So these are our possibilities. Now notice here is 28, and what do we have? Well, we have this opposite side, and also we have, here's the hypotenuse. We have the hypotenuse. So it looks like we're going to be using sine here. That looks bad. It looks like we're going to be using sine. So we're going to have our sine function, which is the opposite over hypotenuse. So this is the sine of the angle. Well, for us, the angle is 28 degrees. And then the opposite side, so the opposite is x, the hypotenuse is 19, and this might look bad. However, you should know that this is just a number. This is just a number. And so what we can do here is just think of this thing as over 1, and then we can kind of cross multiply to get a value, right? So we're going to do 1 times x, that's just x. And then we have 19 times the sine of 28. And that's a number. Now, let me just get something up here. I don't know what I have. That was my email. So here, let me just get up a calculator. Let's go to Google. How about scientific calculator? So this is a very popular calculator for us to use. So here we go. We have we have 19 times the sine. We want this to be in degrees, not radians. Degrees. Click degrees. 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 For the love. Degrees. The sine of what was this? 28. Close paren. Enter. 8.92. Yeah, we're going to do the 100th on this whole unit. So we're going to do 8.92. I'm rounding this up to a 2. So this is 8.92. The measure of this is 8.92 approximately. Okay, let's see another one. Let's see how about something like this, where this is our right triangle. Let's say this side is 32. This angle in here is 41, and then this side over here we don't know. So just a quick reminder. Here is the rundown of our possible functions. So sine of theta is opposite over hypotenuse. Cosine of theta is the adjacent over hypotenuse, and then tangent of the angle is opposite over adjacent. And so here we go. Let us see. We have 41. Now this is our angle. All right, and now let's look. We have the one right across from it, so we have the opposite. And then we have the one right beside it, which is the adjacent. Well, tangent has them both, right? So we're going to use the tangent function. So this is going to be the tangent of 41 is equal to the opposite, which is x, over the adjacent, which is 32. Again, guys, this is just a number. And so what I'm going to do here is I'm going to cross multiply. X times 1 is just x. 32 times tangent is some number. I'm going to have to, the tangent of 41, I'm going to have to put into the calculator. Okay, so good thing I got rid of that. No, I didn't. Here it is. So let's bring the calculator back up. Okay, so make sure you're in degrees. Make sure you are in degrees. Degrees. So this is 32 times the tangent of 41. Enter. 27.82. Let's do that. X is equal to 27.82. And yeah. Okay, I'm going to look at one more. Because those two are basically the same type of problem in that sense. Let me try to get this just a little bit better. All right. Not Picasso here, guys. Okay, so here we go. We have 72. So we have this opposite side, and we have our adjacent side. So we have opposite and adjacent. That is the tangent of an angle. Okay, so let's just go ahead with this. This is going to be the tangent of 72 degrees is equal to the opposite side, which is 25, divided by the adjacent side. And some of you may be wondering to yourself, okay, here we go. This is just a number. I'm just going to cross multiply and go from there. And that's exactly what you'll want to do, except this is going to give you 25 is equal to x times tangent of 72. Now, this is an issue, right? But just remember, this is a number. This would be like x times 7. It might even be 7. We don't know. No, it won't be 7. It's less than 1. But here, what we need to do, right? What we would, if this was x times 7 is equal to 25, we would just divide both sides by 7, right? And this is no different. In fact, that's exactly what we're going to have to do. We're going to have to divide both sides by this coefficient on x. It just so happens that it's gross. It's the tangent of 72 degrees. And so x is equal to, I'm just going to kind of rewrite this down here. X is equal to 25 divided by the tangent of 72. And so I'm just going to go to my calculator over here. What was this? 25 divided by, I'm going to wrap this in parens, the tangent of 72. Close, enter. 8.12, 8.12. Yep. And so we have x is equal to 8.12. Again, the more that you guys do this, the more that you'll realize that these are just numbers. And you just solve this like you would with it, just in place of them being numbers. You know, just think of it as a number, because that's all it really is. All right, guys, thanks for watching.